In this problem, we're looking for c when we revolve around the line y equals 4. So our line of revolution would be way up here. And what that means is this shaded portion will spin up above that line of revolution, and we're going to have a revolved shape like this. And so we can see that we will have now an inner radius here and an outer radius forming an outer concentric circle there. And so we're still looking at the washer or donut method. And in this case, our big R runs from the axis of rotation all the way down to the x-axis, and our inner radius extends from the axis of rotation down to the curve. We're not going to go up only because these equations are unknown to us. We could come up with them, but it would be a lot of work to figure out what they are. Whereas we already know this is y equals square root of x, and this is y equals 4 minus 1/2 x. So that's why we're going to go down instead of up. So this big radius, hopefully you can see, is always 4. Whereas the little radius will be upper minus lower, or 4 minus square root of x for the first shape. And here it will be little r of 4 minus 1/2 x, which will simplify to 1/2 x is equal to that r, because 4 minus 4 is 0, and when I distribute this negative, it makes that 1/2 x positive. So my volume statement will then be the integral from 0 to 4 of my big R of 4 squared minus my little r of 4 minus radical x all squared dx, plus now the integral from 4 to 8. My big R will still be 4 squared, or 16, minus, now our little r is 1/2 x all squared dx. And we could simplify in things, but we don't have to, and it's fine to have it all out so we can see where everything is coming from. Now hopefully you recognized, wait a minute, isn't this a donut or a washer? Shouldn't there be a pie? Of course there should be a pie in both, because it's a circle with the circle cut out.